Hey there, class. Mr. Prusky here. Hope you're having a good day so far. For this is kind of a review lesson of 5.2 day 1, which is factoring. The reason I'm going through this is because it's important to know when to do what. We've taught you all the different, methods for solving, difference of squares, perfect square trinomials, the smiley face method, and factoring by grouping. And it's important to know when to do what, okay? So we're going to kind of go through these examples together to kind of get an idea of the process to make sure we know how to go through factoring using our factor flow chart, okay? So number 1 says x squared minus 4. First things first, is there a GCF we can pull out of here? No, this is a 1. There's no x over here, so no GCF. How many terms do we have here? Well, terms are separated by addition and subtraction symbols, so we have an x squared and a 4. We have 2 terms. Okay, is it a difference of squares? And a difference of squares has 2 perfect squares with a subtraction sign between them. Is x squared a perfect square? Yep, the square root of x squared is x. Is 4 a perfect square? Yep, square root of 4 is 2, and there is a minus sign between them. So this is a difference of squares. So then the shortcut, all we have to do is we're going to put the square root of the first one right here, square root of the last one right here. We're going to put a plus and minus between them, and that is how you factor that. If you were to FOIL that, you would get back to x squared minus 4. And there is your answer. All right, number 2. Okay, is there a GCF we can pull out of number 2? Well, this is a 1 here, so no number we can pull out here. We want the largest number and the smallest exponent that goes into everything. Well, we have an x squared, and we also have an x over here, so we can pull out at least an x. So we're going to pull out an x in front. Divide these all by x. Move this down a little bit. So we're going to have x. We're going to divide everything by x and put the x in front. X squared divided by x, you subtract exponents. 2 minus 1 is just going to be x to the first power, or just x. And then 5x divided by x, the x's are going to cancel, and we get x plus 5. So after we pull out a GCF, now we have to look inside the parentheses and see if we can do any more factoring inside of there. Well, in the parentheses, we have x plus 5. Well, is x plus 5 a quadratic equation? It's actually not, or a quadratic expression, that is, because this one does not have a squared here. Even if it did have a square, we couldn't factor it really, but this is actually as far as we can go because x is not a quadratic expression. We can only really factor quadratics besides doing GCFs and stuff, okay? So this is actually going to be our final answer for this one. X plus 5 we can't factor anymore. It's kind of reduced as far as it'll go. All right, number 3. Number 3 is a good one. So we have 2n squared plus 36n plus 162. Is there a GCF we can pull out of here? Well, is there a number that goes into 2, 36, and 162? Well, what kind of numbers are those? They're all even numbers. What even numbers are all divisible by? They're all divisible by 2. And remember, when we're looking for a GCF, you can only take the, it can't be bigger than the smallest number, right? You can't pull out an 8 here because 2 doesn't divide by 8. So you want to find the biggest number that goes into everything, but it's always going to be, sorry, I have a phone call coming in here. Oops. And there's football. Okay, sorry about that. All right, so we have, so the largest number that goes into 2, 36, and 162 is 2. We can pull out at least a 2. And then, let me just close this really quick here. Give me a second, just so we're not distracted again. Okay, and this one doesn't have there's no n over here, so we actually can't pull out an n, all right? So the biggest number that goes into 2, 36, and 162 is 2, so we can at least pull a 2 out in front, so let's do that. 2n squared divided by 2 is going to be n squared. 36n divided by 2 is going to be 18n. And 162 divided by 2 is going to be 81. So we pull out a GCF. All right. How many terms do we have here inside the parentheses? Well, we got 1, 2, 3 terms, right? Is it a perfect square trinomial? Well, remember, a perfect square trinomial is going to be 2 perfect squares in the front and back, all right? Is n squared a perfect square? Yep, square root of n squared is n. Is 81 a perfect square? Yep, square root of 81 is 9. And the middle has to be 2 times or double these 2 perfect squares or square roots being multiplied together. So what is 9 times n going to be? Well, that's going to be 9n. What's double 9n? Is that 18n? It is. So this is correct. It's going to be a perfect square trinomial. So the shortcut, all you have to do is you're going to do, it's going to be n plus 9, because this is a plus right here. And it's going to be all quantity squared. That's going to be the shortcut. You could also do the smiley face method if you wanted to and go on like this. You could do, so n times n is going to be n like this, and plus 9 and plus 9. If you do the smiley face method, you're going to get 9n and 9n, which equals 18n. Okay, but the shortcut, I would really encourage you to use the shortcut because we're going to need to know how to do perfect square trinomials for what's called completing the square. And so knowing that right now is pretty important, okay? All right, sounds good. Number 4, so our final answer is 2 times n plus 9 all squared. Number 4, we have x squared plus 13x plus 40. All right, any GCF here? Well, this is a 1. This one doesn't have an x. We can't pull out a GCF, and there's not a number or exponent we can pull out of here. How many terms do we have here? Well, we got 1, 2, 3 terms. We have 3 terms. Do we have, let's see here. Is it a perfect square trinomial? Well, x squared is a perfect square, but 40 is not a perfect square. Square root of 40 is not going to come out to a nice whole number like 4 or 5 or something like that. So it's not a perfect square trinomial. So now we're just going to do the smiley face method. So we need factors of x squared. Well, in fact, the only thing that can multiply to x squared is going to be x times x. So we can put those in front and know we're good. These are both positive, which is nice. So now we know these are both going to be positive right here. Now we need factors of 40 that are going to add to 13. Well, factors of 40, well, we got 1 times 40, 2 times 20, 4 times 10, and 5 times 8. Those are the big ones. So which ones are going to add up to 13? Well, 4 times plus 10 is, that's going to be 14. This is going to be 22. What about 5 times 8? Is that 13? It is. So we're going to put 5 here and 8 here, or you can flip them around. That's totally fine. This is actually going to work. If we do this, we're going to get 5x, and we're going to get 8x, which equals 13x. So our final answer is going to be x plus 5 times x plus 8. And that is our final answer. Okay, moving on. You guys are doing great. Getting the process down, doing a great job. Number 5, let's do blue now. 7v squared plus 59v minus 36. Okay, so we need numbers. We need to check if there's a GCF first of all. Is there a GCF? Well, the smallest number is 7, and 7 is a prime number, so the only numbers that go into 1 and go into 7 are 1 and 7. Does 59 divide by 7 or no? It doesn't. 7 times 8 is 56, and then 36 is not divided by 7. 7's a prime number, and I think 59 is also a prime number, so there's no GCF. All right, how many terms do we have here? We have 3 terms, and is it a perfect square trinomial? Well, 36 is a perfect square, but is 7v squared a perfect square? No, square root of 7 is not going to be a nice number. That's going to be an irrational number. So it's not going to be perfect square trinomial, which means we're going to be doing smiley face method. So what multiplies to 7v squared? Well, that's going to be 7v times v. All right. Now what kind of signs do we need here? We have a positive here, but we have a negative here. The only way to multiply to negative 36 is going to have a positive and a negative somewhere. We're going to have to kind of guess and check and see. And now we need factors of negative 36. So we're going to have negative 1 times 36, 1 times negative 36, negative 2 times 18, 2 times negative 18. What else do we got? Negative 3 times 12, 3 times negative 12, and negative 4 times 9, or 4 times negative 9. All right. So we need to match up something with 7v and v that's going to give us 59. What do I got for this one? So let's just try some things. Let's try 3 and 12. Let's do, yeah, why not? Let's do 3 and 12. Let's see here. Yeah, we'll try it. We're just going to try something to get the process down. So we're going to put, it needs to end up being a positive 59b, which is a pretty high positive number. So I'm going to put the 12 with the 7 to give it be a high positive number, and we're going to do negative 3 right here and see what happens. So negative 3 times v is negative 3v. 7 times 12. Sorry, I didn't calculate this here. That's going to be 84. So this is going to be 84 minus 3, which is 81. So we're pretty high here. So these numbers are pretty big. So we're probably going to need to pick numbers that are kind of closer together, like these 4 and 9. Okay, so let's go ahead and try those numbers instead. Let's try something different here. Let's try. Why don't I try putting? I'm going to put the 9 with the 7v. I'm going to put the minus 4 with the 4v. So we got negative 4 times v is negative 4v. 7v times positive 9 is 63v. Well, look at that. What's 63 minus 4? Is that 59? It is. So our final answer is going to be 7v minus 4 and v plus 9. And that is our final answer. Okay, next one. Number 6. Same process. Is there a GCF we can pull out of here? Well, I checked. Let's do 56 divided by 3. The only factors that go into 3 are 3 and 1. So let's try dividing 56 by 3. And that's 18.6 repeating. So that's not going to be, no GCF we can pull out here. This one doesn't have an N either. So we're going to have to do, check if it's a perfect square trinomial. We have 3 terms, right? Is it a perfect square trinomial? Well, square root of 3n squared is not a perfect square. 56 is not a perfect square. So it's not a perfect square trinomial. So we're going to be doing the smiley face or guess and check method. So what multiplies to 3n squared? Well, we got 3n and n. That's the only thing that works. We have a negative here, but we also have a positive here, which means these both have to be negative in the middle. The only way to get a negative there with, but a positive at the end, it's going to be 2 negatives. We need factors of 56. We need negative 1 times 56. Negative 2 times, what is that? Not so good with mental math. 28. These are both negative 2, by the way. And then 56 is divided by 4. So we got 4 and 14. I'm just checking I'm just going up. I'm dividing 56 by 2, 3, 4 until I get numbers that work. And I'll show you when you can stop. Okay, so we got negative 4 and 14. 56 divided by 6 does not work. 56 divided by 7 does work. So we have negative 7 times negative 8. Okay, and when you can stop is when these numbers start to go the opposite way. If we go up to negative 8, it's going to be negative 8 times negative 7. Well, we already have negative 8 and negative 7. It's just flipped around. Okay, so basically you're gonna be dividing by numbers that work until you get to these numbers start to reverse, and then you're going to be, that's where you can stop. So these are all the factors of 56 right here. Okay, so what should we use that's going to give us negative 29n? Well, so we need the 3n and n. We're not going to pick these really big numbers, I don't think, because they're not going to work. Let's try negative 7 and negative 8. Why don't we try let's put negative 7 right here and negative 8 right here. We're just guessing and checking and see what works. So negative 7 times n is negative 7n. 3n times negative 8 is negative 24n. So that's close, but that's going to be negative what? Negative 31n. So that's not the answer we want. So we got to try something different. Let's try flipping around the 7 and the 8. So let's put the 8 right here and the 7 right here. So negative 8 times n is negative 8n. 3n times negative 7 is negative 21n. Well, look at that. That's going to be negative 8 plus or minus 21 is negative 29n. So our final answer, we got it. It's going to be 3n minus 8 times n minus 7. I would say mostly when we're doing these kind of solving problems, you're not going to use these really big numbers so much. You're probably going to use mostly these numbers that are kind of close together and stuff. That's kind of a trick that I would say. I rarely find that the answer is something like negative 1 times negative 56. That's pretty... If it is something like that, you know the middle number has to be something huge in the negative direction or huge in the positive direction, okay? All right, there's our answer. Usually we want to guess and check with some of these middle ones right here. All right, 2 more examples. Number 7. We have 6n squared plus 43n minus 40. All right, is there a GCF? Well, the factors of 6 are 1, 2, 3, and 6, and I don't think any of those numbers go into 43. 43 is probably a prime number, so there's no number we can plot here. This one doesn't have an n, so there's no GCF. All right, how many terms do we got here? 3 terms. Is there, let's see here, is there a perfect square trinomial? Well, square root of 6n squared is not going to work. Square root of negative 40 is not going to work, so that's not a perfect square trinomial. So now we got to do our guess and check. It's going to be smiley face method. So we need factors of 6n squared. So we can try either n times 6n or 2n times 3n, a variation of that. So I'm not sure what's going to work. We need factors of negative 40, so this is a positive and negative, so we're going to need a positive and a negative here. Let's just try factors of negative 40 would be negative 1 times 40, or the opposite, negative 2 times 20, or the opposite. I think we did this before, negative 4 times 10, or the opposite, negative 5 times 8, or the opposite. And then when we do this again, it'd be negative 8 times 5. To see how these are going to flip around, we don't need to keep going. That's where we stop. So we just got to guess and check here. Let's put 2n and 3n. We need to end up with it being pretty positive. It needs to be a pretty positive in the positive direction. So let's try 20 and negative 2, for example, here. So let's put 20 right here and negative 2 right here and see what happens. Just to give it a try. So negative 2 times 3n is negative 6n. 2n times 20 is 40n. Well, if we get that, that's going to be 36 or 34n. That's not going to work. But that's not the ones that's going to work. All right, let's try something different. Let's try 8 and 5. Well, let's try 8 and 5. Let's try 10 and 4, actually. Let's go plus 10 and minus 4. What's that going to be? That's going to be, well, that's going to be 30n. This is going to be negative 8n. So we're actually going the wrong direction here. So I don't think that 2n and 3n are going to work for us. So you can just try all different combinations and see what happens. But I think what we're going to need to do is we're going to need to do 6n and n. 6n and n. And let's try the combination. So 43, it's got to be more positive here. So I'm going to put plus 8 with this 6, and I'm going to put minus 5 with this. So let's see how that works. We got negative 5 times n is negative 5n. 6n times 8 is going to be 48n. Well, it's 48 minus 5. That is 43n. So we found the right combination. And so, like I said, it's guess and check. There's not really like a good way to solve this faster. It's just kind of you have to kind of see the patterns and just be good at kind of guessing and seeing what numbers are going to work. But this is the correct answer here. 6n minus 5 times n plus 8. All right, last one, number 8. 10n squared minus 37n plus 30. Do we have a GCF here? No, 37 is a prime number. Factors of 10 are 1, 2, 5, and 10. None of those go into 37, so that's not going to work. So no GCF. Is it a perfect square trinomial? It is not. 10n squared is not going to work. 30 is not a perfect square either. So we're going to do our guess and check, smiley face method again. So factors of 10n squared are going to be 10n times n or 2n times 5n. Factors of, so this is a negative, but it's also a positive here. This one's going to be nice. So it's going to be 2 negatives in the middle, we know for sure. Factors of 30 are going to be negative 1 times negative 30, negative 2 times negative 15, negative 3 times negative 10, negative 5 times negative 6. I think those are the basic ones. So we need to just guess and check. We need to end up with a pretty negative middle number here. So we need kind of a big negative number in the middle. So let's try 10n and n for now. We'll see how this goes. So to end up with 37 in the middle, let's try. So what we know is since these are both going to be negative, whenever we add these together, they're going to end up being more negative, right? They're not going to end up being there's it's not gonna like cancel out like this last one over here. We had this 48 and it canceled out. It got less negative or less positive by subtracting 5n. But these are both negatives, so we need something that's gonna end up being both. It's gonna contribute. It's gonna be start negative and get a little bit more negative. So let's just try. Let's try just 10 and 3 right here. Let's just see how this works. That's gonna be what? That's gonna be negative 10n. This is going to be negative 30n, so that's going to be negative 40n, so that's not going to work. So that one's not going to work. Okay. So I guess we should let's try 2 and 5. Again, I want to finish up the video here pretty quick. So let's try 2n and 5n. And let's also try negative 5 and negative 6, see how this goes. So we got negative 25n here, and we also have negative 12n, and that's going to equal, we got the right answer, it's going to be negative 37n. So that's the correct answer. We have 2n minus 5 times 5n minus 6, and that is our final answer. And we're good to go. Okay, thank you for watching.